Hi, my name is Lindsay Ehrlich, and this is my Physics Lab 1 charge tapes. So the purpose was to observe the interactions between and determine the amount of excess charge on charged pieces of tape. As a quick results preview, the charge on each tape was found to be 1.167 times 10 to the negative 8 coulombs, and the number of electrons lost by each tape was 7 times 10 to the 10th electrons. Some key concepts to keep in mind: Newton's second law, of course. A system's change in momentum is proportional to the net force applied, and we have the equations displayed. And Coulomb's law describes the force of attraction or repulsion between two electric charges, I also have the equation there. And gravitational force describes the attractive force between any two objects with mass. The equation is also on the slide. Some initial conditions. The tape mass was 2 times 10 to the negative 4th kilograms. The tape length was 0.2 meters. Tape width was 0.02 meters. Tape area was 0.004 meters squared. The atom area was 1 times 10 to the negative 20th meters squared. Number of atoms, which is the tape area divided by the atom area, was 4 times 10 to the 17th atoms. And these are important numbers to keep in mind for our later calculations. The procedure was to first place a base tape on a flat surface, create a U-tape by placing a tape on top of the base tape, then quickly peeling it off, and you can see the diagram for that in the top right. Then check that the U-tape is working properly by observing its interaction with your hand. It should attract. Then observe the interaction between two U-tapes. Next, observe the interaction between a U-tape and a charged object, which in this case was a pen rubbed on a piece of clothing. Then we suspended one U-tape between two neutral objects and observed the interaction between this U-tape and the other one hovered beneath. So some observations. We found that the interaction between two U-tapes repelled, the U-tape in the hand attracted, the U-tape and the charged object also attracted. The object was negatively charged after being rubbed on the piece of clothing, so the rubbing motion transferred the electrons from the clothing onto the object's surface, so we can conclude that the U-tape was positively charged. And then the suspended U-tape and the other U-tape repelled each other. So the system was the other U-tape, and the surroundings were the suspended U-tape and everything else. And distance between the two U-tapes was 0.025 meters. Some calculations here. The magnitude of the gravitational force was 1.962 times 10 to the negative third. The magnitude of the electric force was 1.962 times 10 to the negative third. The electric charge was 1.167 times 10 to the negative eighth coulombs. The number of electrons lost was 7 times 10 to the 10th electrons. The ratio was 5.7 times 10 to the 6th atoms per electron, and you can see all the formulas that we used in the top right. Here's our first computational model, which was using point charges. The blue dots were the top and bottom tape. The green arrow is the electric force, the red arrow is the gravitational force, and the charge on the tape we found to be 1.21 times 10 to the negative 9th. This is what the computational model outputted. Here's a second computational model using line charges now instead of point charges. Some important things to note in the code. I have the function for the electric field in the bottom left. And in the second panel, you can see that the inner loop calculates the field contributions from each segment of the bottom tape, then multiplies the net electric field by the segment's charge to find the net force. And we found that there's a slight discrepancy between calculated values and the model values, which is to be expected. So in the computational model, the line charges were more accurate than the point charges, and some sources of error that may explain the discrepancy between the computational models and the observed data include external forces not accounted for, like some other object nearby was charged. Distance measurements were eyeballed as accurately as possible, so those might not have been super precise. Some additional questions. What if electrons and protons had inverse charges? All observations will remain the same. The charged pieces of tape are now negative, however, they would still repel each other and attract to the positively charged pen. Why must we handle the charged tapes as little as possible? The charged tapes begin to neutralize when handled or come in contact with other objects as they try to gain back lost electrons. Thank you.